Welcome to Coach Eichner's Math. Today we'll be talking about area and perimeter of triangles. First thing to look at is our formula. Area equals 1/2 base times height. This has actually been derived from our rectangle formula. If you want to look at it real quick with me, the rectangle is always base times height. Well, if I take the biggest triangle I could draw within that shape, that triangle right there would be half of the rectangle. Now, they've gone a step further when they proved this, and they said, well, as long as all three vertices hit, right, this triangle isn't quite as obvious to tell that it's half of that triangle, but it would be. And they've already proven that for us, so we don't have that burden today. What we want to make sure we know is base times height, just like a rectangle. Notice that the base and the height are always meeting at a 90-degree angle. That'll be important. And then we're going to take half of that. The perimeter is obviously adding up all three sides. So let's look down at example number 1. Example number 1, a base and a height. It doesn't matter which I call which. Some people are going to argue that 14 is the base, or that 14 is the height. Well, if I turn my paper like this, I could argue now that 14 is my base. So really, as long as I have the base and the height with the 90-degree angle in between them, it does not matter which you call each, as long as you keep it the same through the whole problem. Our formula for area, 1/2 base times height. Let me type that in the calculator real quick. I'd say 0.5 times 48 times 14 is 336 units squared. Again, remember, U stands for units. This is important because while we're writing units, that's declaring that they didn't tell us how big our units are, but, in this case they did. Instead of saying units right here, I would say inches, because they did denote our units. It's important because an inch is not the same as a foot, is not the same as a yard, and so on and so forth. Not the same as a mile. So if we don't declare what our units are in, someone could walk up and misread our work and tell us that we are going 336 millimeters, which would not be the same size triangle. So there's my area formula. Looking at the perimeter, I need to add up all three sides. So we got to take a trip back to our right triangle work and remember the formula for Pythagorean's theorem. If I ever know two sides of a right triangle, A and B, I can always find the third C. Say 14 squared plus 48 squared equals C squared. So 14 squared plus 48 squared gives me 2,500, which equals C squared. A lot of people make mistakes right here. They try to divide by 2. They try to do all kinds of crazy things. Make sure that the opposite of the square is the square root. So if you go second x squared, see the square root button, and then the easiest thing to do here is to say second, and then come down here and you see where it says ANS, that stands for answer. So that's going to say the square root of the previous answer. That way, if it's not as pretty a number, it's just as easy to type in. So as I'm looking at it, I hit enter. That is 50. So C must be 50. So for the perimeter, I'm going to say 14 plus 48 plus 50, and that is 112. And I would put inches. Okay, let's look down at example number 2. Example number 2. We know the sides are congruent, which makes these angles congruent, which makes these similar triangles. Or excuse me, not similar, but congruent triangles. This piece right here would also be 2. And again, I'm in a situation where I know A, I'm looking for B, and I know C. So A squared plus B squared equals C squared. A is 2, B and C is 6. So 4 plus B squared equals 36, or B squared equals 32. Got to take square root. B equals the square root of 32, which we know how to work this out. We can say 32 splits up into 4 and 8, which is 2 and 2, which is 2 and 4, which is 2 and 2. So I have a pair of 2's, I have a pair of 2's, or I could stop right here and say I have a pair of 4's that come outside and 2 left over. So B equals 4 radical 2. Now, why was it important to find that? What I mentioned in the first couple of problems, your base and your height must be at a perpendicular angle. So it is important to know that this inside piece is the height, not 6. So let's look at the base. The base would be that whole distance of 4. The height would be 4 radical 2. And the area would be 1/2 4 times 4 radical 2. Well, half of 4 is 2. 2 times 4 is 8. So I would say 8 radical 2. And I would say units squared, but I'm not going to try to squish it onto the paper for you so that it's easier to read. Please make sure that you list your units. Looking at the perimeter of my outside, so 6 plus 6 plus 4. So 6 plus 6 is 12. 12 plus 4 is 16. Let's look down at example number 3. So looking at example number 3, there's a little bit different situation here. I talked about it on the problem before, but in case you didn't recognize it, I said, well, these two have to be congruent because they are shown as congruent, which means the opposite angles must also be congruent. Congruent sides means congruent angles. So if I take the time and remember back, we know we have 180 degrees in a triangle. I know I have 90 degrees here, and if they are congruent angles, that would make this a 45, 45, 90 triangle. So right now, you have two choices. You can use sine, cosine, and tangent. Figure out which one you want to use and solve for one of our missing sides. Or you can use your special right triangles, where we know that those two sides have to be x, and this side would be x radical 2. So 10 equals x radical 2. Divide by radical 2 on both sides. X equals 10 divided by radical 2. If you remember your shortcut, you can just jump down here and say that x equals 5 radical 2. Divide by 2. Multiply by the square root. If you don't, it's square root of 2 over square root of 2, which is 10 radical 2 divided by square root of 2 times square root of 2 is just 2. Well, 10 divided by 2 is 5. Add the radical. So, now that I've done that, we know that the base and the height are off my 90 degrees, so they are both going to be 5 radical 2. So the area is 1/2. I'm going to put this in parentheses, 5 radical 2 squared. So what does that mean to me? I'm going to come down here and do this in a different color for you. 1/2 5 radical 2 squared means 5 squared, and radical 2 squared. Well, 1/2 is 1/2. 5 squared is 25. And the square root and square cancel out, which gives me 2. Well, 1/2 and 2 cancel out, which means that my area is just 25 units squared. One more time in case you didn't follow. Square and square root canceled out because I had to take the square. It was base times height. So I have base times height is the same as saying the height squared or the base squared because they're the same number. So in squaring it, I said 5 squared is 25. The square root of 2 squared, square root of 2 times square root of 2 is just 2. Square and square root cancel, as they should. Left me with 2. Well, if I take half of 25 and then double 25, I'm going to end up right back at 25, so my 1/2 and my 2 cancel. Perimeter. Perimeter is going to be the 3 sides added together. Well, we know that we have 10, and we know that we have 5 radical 2 and 5 radical 2. Well, if I add 5 radical 2 and 5 radical 2, I end up with 10 radical 2. Unfortunately, I can't add these 2 pieces, so I'm going to say here, let me go back to a different color so you can see it. I would say 10 plus 10 radical 2 and leave that as my final answer. 10 plus 10 radical 2 units. As those 2 pieces will not go together without making an ugly decimal, and we don't need to do that right now. Let's look down below at example number 4. My challenge to you is to use what you know. This is a rectangle on the bottom and a triangle on the top. Do your best, see if you can put this together. Take a moment, pause the video. All right, let's look just at the rectangle first. If I take the rectangle area and I add the triangle, I'm in good shape. So let's just look at the rectangle first. Rectangle is just base times height. So the area of my rectangle is base times height, or 5 times 12, which is 60. Plus the area of my triangle. Let's look at my triangle here. It's got a base of 12 and a height of 3. So my area or my triangle formula is 1/2 base, which is 12, times height, which is 3. Well, 1/2 of base is 6, times 3 is 18. So just that easy, I can say 60 plus 18 gives me 78, which means that my area would be 78 units squared. And just like that, it is that easy to put together 2 shapes that we know. Don't try to do it as one shape. Take advantage of the fact that we know a rectangle and we know a triangle, and put those together. This has been Coach Eichner's Math. I hope you've enjoyed, and hope you have a great rest of your day.